Hello and welcome everyone. In this video, we will have a look at TCP/IP protocol suite. Have you ever wondered how your computers talk to other computers on your local area network or to the remote computers over the internet? Well, understanding the intricacies of how computers interact is an important part of networking. So in this video, we will make an attempt to discuss the concept of communication from the very basic fundamental level that needs to be understood by everybody. Communication between the computers on a network is done through protocol suites. A protocol suite consists of a layered architecture where each layer depicts some functionality which can be carried out by a protocol. Each layer usually has more than one protocol options to carry out the responsibility that the layers adheres to. The most widely used and the most widely available protocol suite is the TCP/IP protocol suite. It is named after two of the most common protocols, TCP and IP. TCP stands for Transmission Control Protocol, IP stands for Internet Protocol. It represents a suite of protocol used on almost all modern communication systems, such as mobile phone, home Wi-Fi router, layer 3 router, layer 2 switches, tablets, and PCs or laptops. It is the network model used in the current internet architecture. This is the TCP/IP is a four-layer model. The layers are as follows: application layer, transport layer, internet layer, and network interface layer. Let us have a brief overview of each layer, starting with the application layer. This is the top layer of the TCP/IP protocol suite. It includes the applications and processes that uses the transport layer protocols to deliver the data to the destination computer. This is the layer where any user interacts with the application. Some of the examples of this application include email, web browsers, telnet clients, and FTP clients. The application layer sends to and receives data from the transport layer. So the next layer we are going to discuss is the transport layer. It is the second layer of TCP/IP model. The position of the transport layer is between the application layer and the internet layer. It provides the means for the transport of data segments across the internet layer. Transport layer sends Transport is concerned with end-to-end, that is host-to-host communication. The transport layer sends data to the internet layer when transmitting and send data to the application layer when receiving. It defines the level of service. It also defines the status of the connection used when transporting the data. The main protocol included in this layer are TCP and UDP. TCP stands for Transmission Control Protocol, which provides reliable, connection-oriented transport of data between two endpoints. UDP stands for User Datagram Protocol, which provides unreliable, connectionless transport of data between two endpoints. The next layer is the internet layer. This is the third layer of the TCP/IP model. The position of the internet layer is between the network interface layer and the transport layer. It is also known as the network layer. Internet layer pack data into data packet known as IP datagrams, which contains source and destination IP address information that is used to forward the datagram between the host and across the network. The main purpose of this layer is to organize or handle the movement of data over the network. You can say it is responsible for routing of IP datagrams. The main protocol used in this layer is IP. The other protocol included are ICMP, ARP, RARP, and IGMP. The internet layer receives the data from the transport layer when sending the data and receives the data from network interface layer when receiving. The next layer is the network interface layer. This is the fourth layer of the TCP/IP model. It is also called network access layer or data link layer. The network access layer transmits data on the physical network when sending and transmits data to the internet layer when receiving. This layer provides physical access to the network. Network layer defines details of how data is physically sent through the network, including how bits are electrically or optically signaled by hardware devices that interfaces directly with the network medium, such as coaxial cable, optical fiber, and twisted pair copper wire. It helps you to define details of how data should be sent using the network. Ethernet and Wi-Fi are some examples of network interfaces of this layer. In the updated TCP/IP model, network interface layer is divided into two layers, data link layer and physical layer. The data link layer is responsible for creating the frames that move across the network, and this frame encapsulates the packets and use MAC address to identify the source and destination. Physical layer encodes and decodes the bits found in frame and includes the transceivers that drives and receives the signal on the network. Let us discuss a TCP/IP example. Let's see how the interaction between computers over the network through TCP/IP protocols would take place in the form of client-server architecture. Client requests for a service while the server processes the request for a client. Now, since we have discussed the underlying layers which helps the data flow from host to target over a network, let's take a very simple example to make the concept more clear. Consider a data flow when you open a website. The information flows downwards through each layer. On the host machine, at the first layer, HTTP request is formed and sent to the transport layer. Here the TCP protocol assigns some more information like sequence number, source port number, destination port number, etc. to the data coming from the upper layer so that the communication remains reliable. At the next layer, IP adds its own information over the data coming from the transport layer. This information would help in packet traveling over the network. Lastly, the network interface layer makes sure the data transferred to or from physical media is done properly. This information travels to the physical media like Ethernet and reaches the target machine in the forms of zeros and ones. On the target machine, the same series of interaction happen in the reverse order. The packet is first received at the network interface layer. At this layer, the information is added by the client network interface layer, is read, and rest of the data is passed on to the upper layer. Similarly, at the network layer, the information sent by the network layer protocol of host or client machine is read, and rest of the information is passed on to the upper next layer. Same happens at the transport layer, and finally the HTTP request sent by the host application is received by the web server. That's it for today. Thank you for watching this video. Please subscribe for more videos.